In this video, we have a question about a shape, and it mentions in the question that the measurements have been rounded to the nearest metre. In exam questions, this nearest should indicate to you straight away that you are working with bounds, so that is your clue to the question. Because we are talking about a shape that hasn't been given as a diagram, my advice to you would be to always draw the diagram first. So we can see here we have a rectangle and we have a width of 18 metres and a length of 17 metres. Doesn't matter how you label those up, you will get the same answers regardless. Now the information in the question says that both of these measurements have been rounded to the nearest metre. That means we are taking our 18 and we are calculating an upper bound and a lower bound for the 18 and also doing the same for the 17. When we are talking about rounding to the nearest unit, in this case metre, we are talking about rounding to the nearest 1. These ones are divided by 2 to find your upper and lower bound. We have a value to add and subtract of 0.5. So our upper bound is plus 0.5 on each of the measurements, and our lower bound is subtract 0.5 from each of the measurements. So we have an upper bound of 18.5 metres and a lower bound of 17.5 metres. For the 17, our upper bound is 17.5 metres and our lower bound is 16.5 metres. We are asked to find out what the maximum perimeter would be. We should know the perimeter is the distance all the way around a shape. Now, if we were looking for the biggest distance that could possibly be, we would be looking to calculate the values if our sides were the upper bounds of each of the measurements, as when you add them together, the biggest measurement should give you the biggest value. So in this case, we are looking to replace these measurements with 18.5 metres and 17.5 metres. And we're taking up the distance all the way around the shape, so we are adding them up together to give us 18.5, add 17.5, add 18.5, add 17.5. And we can do that in a column method, or we could add two of the measurements together and double it. Does not matter which one you choose to do for your addition. So 5 add 5 add 5 add 5 is 20. So 0 down, and we will carry the 2. 8 add 7 is 15. 15 add 8 is 23. 23 add 7 is 30. And 30 plus the 2 that we carried on is 32. So we are writing down 2 and we are carrying over the 3. 1 add 1 add 1 add 1 add 3 is 7. So that means our maximum perimeter for this rectangle is 72 metres. Press pause while you try the your turn question. Your turn. A rectangle has a width of 13 metres and length 10 metres. Both are to the nearest metre. What is the minimum perimeter? Remember, this word nearest should make you think of bounds straight away. The question is talking about a shape, but a shape hasn't been given to you in diagram form, so I would draw the shape. We have a side of 13 metres here and a side of 10 metres there. Both have been rounded to the nearest metre, so we're looking for the upper and lower bounds for both of these values. So starting with our 13, we have an upper bound and a lower bound, and for the 10 we have an upper bound and a lower bound. Both have been rounded to the nearest metre, so that is 1, and we would divide those by 2 to work out what we must add on and subtract from our units. In this case it is 0.5. So for our upper bounds we must add on 0.5, and for our lower bounds we must subtract 0.5. That gives us upper bound measurements of 13.5 metres and a lower bound of 12.5 metres. And for the bottom we have 10.5 metres for our upper bound and 9.5 metres for our lower bound. We are looking for the minimum perimeter, so that is the smallest distance that we can have around our shape. That means we are using the smallest possible measurements of 12.5 for our width and 9.5 for our length. We will replace the measurements on our diagram to give us 12.5 and 9.5, and remember we will add up the measurements to find our perimeter. So we have 12.5, 9.5, 12.5 and 9.5. 5 add 5 add 5 is 20. 0 down, carry the 2. 2 add 9 is 11. 11 add 2 is 13. 13 add 9 is 22. And add the 2 gives us 24. 4 down, carry the 2. 1 add 1 add 2 gives us 4. So our minimum perimeter is 44 metres.